8.3 example 2, we're going to now graph our equation or quadratic function in standard form. Remember, standard form is ax squared plus bx plus c. Let's take a look at this step by step. So in this question, we're going to graph our function and we're going to look at all the components and then we're going to describe the domain and range. So our first step is we're going to find and graph the axis of symmetry. So remember, we're going to use the formula for the axis of symmetry, x equals the opposite of b over 2a. From our equation up here, the 3 is our a and the -6 is our b. When I plug it in, I get the opposite of -6 over 2 times 3. The opposite of -6 is +6 over 2 times 3, which is 6. So 6 over 6 is 1. Therefore, our axis of symmetry is x equals 1. The next step is we're going to find the vertex. To find the vertex, I'm going to use this axis of symmetry, this 1, as the x coordinate of the vertex. Let's take the 1 and let's plug it into our function and we can find the y of our vertex. So we're going to have 3 times 1 squared minus 6 times 1 plus 5. Don't forget the order of operations. Do 1 squared. First is 1 times 3. Minus 6 times 1 is 6, plus 5, and we get 2. Therefore, our vertex is 1, 2. So now our next step is we're going to find the y-intercept of our equation. We said earlier that the y-intercept is just the c of the equation, which in this case would be 5. Remember, the y-intercept is just when x equals 0. Imagine I plugged in 0 for the x's. This term would just cancel out, and this term would also just cancel out. So the y-intercept is always just the constant term at the end, and in this case, it's going to be 5. So that means that the point 0, 5 is going to be on our parabola. Now, since our parabola is symmetric across the line x equals 1, I can find the symmetric point on the other side of the parabola. It's easier to find this point when you actually look at the graph. So let's take a look here. Go step by step. Start with the axis of symmetry, x equals 1. That's this vertical dotted line here passing through the x-axis here at 1. Next, plot your vertex, the point 1, 2. Here's our vertex here. Next, we're going to plot the y-intercept, which is the point 0, 5. And then I want to draw its symmetric point across the axis of symmetry. Because this point is just one box to the left of this axis of symmetry, I can put a point one box to the right of the axis of symmetry, which becomes the point 2, 5. And then I can draw my smooth curve right through these 3 points here. I really only need these 3 points to draw a parabola. If I wanted to, I could make a t-table and find more points, like how we were doing in section 1 and 2, put the vertex in the middle, go 2 down and 2 up, but this is the faster way to do it. Our next step is now we're going to say the domain and range. The domain is all real numbers because our x's can be any number we want here. The range, we need to look at the vertex and how the arrows are pointing. The vertex y is right here at 2, and our arrows are pointing up, so the range is y is greater than or equal to 2. Let's listen to Big Ideas explain another one of these.
Graph f of x equals x squared minus 2x minus 3. Describe the domain and range. Notice that a equals 1, b equals -2, and c equals -3. Find the axis of symmetry. First, write the equation for the axis of symmetry, x equals -b divided by 2a. Then substitute 1 for a and -2 for b to get x equals the negative of -2 divided by the quantity 2 times 1, or x equals 1. So the axis of symmetry is x equals 1. Graph the axis of symmetry. Because the axis of symmetry is x equals 1, the x-coordinate of the vertex is 1. Use the function to find the y-coordinate of the vertex. First, write the function. F of x equals x squared minus 2x minus 3. Evaluate the function f when x equals 1 to find the y-coordinate of the vertex. F of 1 equals 1 squared minus 2 times 1 minus 3, which simplifies to 1 minus 2 minus 3, or -4. So the vertex is 1, -4. Plot the point 1, -4. Because c equals -3, the y-intercept is -3. So plot the point 0, -3. Because the axis of symmetry is x equals 1 and the point 0, -3 lies on the graph of the function, the point 2, -3 also lies on the graph. Plot the point 2, -3. Then draw a smooth curve through the points. Using the graph, you can see that the